Okay. We all get 1080 a semester, a big chunk of the entire, the big chunk of what we're doing is what we're doing now. And of course, the fundamental theory of calculus says that you have a continuous function. It's f of b minus f of a, where big F is an antiderivative of L. And because of the ease of this, this makes it a very important problem. How can we find an antiderivative? This isn't always so easy. It's not just an algorithmic process like derivative, right? Once you know the product rule, chain rule, and some basic things with sine, cosine, px, and so forth, you just go with it. This requires a little bit of thought, and unfortunately, doesn't always work in the sense that you can't always find an antiderivative in terms of elementary functions that you're used to. Nonetheless, it's very important. So what you'll get is 1080 is you'll get integration by parts. You will get trig substitution. We talked about yesterday a little bit, although I formally won't do this. If there's anything like that on the exam, it will be like on the quiz. Since I'll tell you what to do. You'll do something called partial fractions, which isn't really integration at all. It's just a way to rewrite things. There are two basic ways to integrate. There are two basic techniques in it. One of them is use substitutions. The other one is called integration by parts, right? And that's basically it. Once you know substitutions, integration by parts, that's basically almost the entirety of the trig bag up to some special tricks like Feynman trig. There's some other things to do as well, but the bulk, 99% of what you can see is substitutions and integration by parts. Now the substitution rule is this. Here we make some assumptions that if you have limits here, the g prime or the g of x is continuous on the interval and differentiable on the interval as well, and that f is continuous with range. This was f of u, and the trick here was to substitute u of x, u prime of x, and these kind of problems range from the very, very easy to the almost impossibly hard, right? Looking for these kinds, right? Because visualizing it looks easy up here, but practically sometimes it's difficult. What does U substitution do? It sort of unravels the chain rule a little bit, so you can see things a little bit. This looks clearer in this. So U substitutions unravel the chain rule. Integration by parts unravels the product, right? So examples, examples. There's an important function. And this is very important. So this is very frustrating because this is made up of two pieces that I can integrate easily, right? Antiderivative of x, easy, 1/2 x squared. Antiderivative of sine x, negative cosine x, no problem. Antiderivative of this, not so clear. Please do not write 1/2 x squared negative cosine x. That's not true. Because and actually that sort of shows you what the problem is, that when you do that, the product rule doesn't work out at all. What integration by parts does is it sort of undoes the product, just like this undoes the chain. Integration by parts is often a great Hail Mary. That is to say, when you look at something and you try a couple of new substitutions not working out for you, by parts. Sometimes that'll make things fall apart. Here's the whole deal with parts. Let me start with taking the derivative. It's like I said, this is this basically hovers on the product. It's namely. So what happens when I take the derivative of this? This is product, right? So everybody gets their turn to get the derivative taken. Let's do this. This way. So this. This is equal to this minus this. You agree with that? Right. All this is just f of x, g prime of x is equal to this thing. Now, integrate this. And this is it. It's two parts. So if this exists, then the integral should be the same. So let me write it out in my story. By the way, this is the antiderivative of this derivative. So this is just adding back to g of x. But this looks like nothing, right? I mean, what did I do? I wrote down the product rule, rearranged some stuff, and then integrated it back, right? I mean, what good is possible to do? Well, let me give you an application to kind of show you what's happening here, and then I'm going to give you something more concrete than like here. Look at the parts point. Here, let's look at the role of f of x. In this, and this would be x. Or I'm sorry, g prime of x. Now the parts formula says that this is f of x, g of x, minus f prime of x, g of x. So what, notice what parts does is you got two functions f and g. Here is f times the derivative of g. That might be hard to integrate. Maybe the derivative of f times g is easy, right? So notice how the derivative roles change. Right? F g prime might be hard, f prime g might be easy. F of x, g of x is x. Oh, by the way, if g prime of x is sine x and g of x is negative cosine x, we won't worry about constants here. So this is negative x cosine x minus, what's f prime of x? 1. And g of x is negative cosine x. Now notice my original problem, integrate x sine x, is very familiar. Parts turns this into now, I've just got to integrate cosine. So this is minus x cosine x cosine x. And it's going all over, so plus. Now, let me show you how to do it practically. So let's think of this way. This is like a U substitution in notation. This is not a U substitution. So what we usually do when we're confronted this problem is often we write U as f of x and d is g prime of x dx. And now use this to fill in. U is f of x. And this is dv. It's this. Now fill in u by taking the derivative of this, and fill in v by taking the antiderivative of this. And the parts formula says this is u v minus v, and this piece right here is du. So sometimes you see this way, u to v, u v minus the other one v. Let me point out that if you have limits here, A to B, then you evaluate this from A to B. And this is parts is different than U substitutions in the sense that you're not making a substitution, you're doing a rearrangement. The limits are the same. I never change the variable. You have to change the numbers if you have a U substitution. Doing parts, don't. So let's get our answer. X. I want to do this. So couple gut checks along the way. I like to pick my U, my dV. I know that I've done this in a way that makes sense. If when I put the UDV back, I get this thing into the right. Now, how do you pick? When we do think about parts, there's only so many things to pick, right? There's only so many parts to this. I could pick dV as x dx or e to the 2x dx. Here is my good rule of thumb. For my dV part, what I've got to integrate, I pick the biggest, ugliest piece, this thing that I can integrate sort of in my head. What's the most complicated piece of this that you can integrate pretty much anything? The e to the 2x. Now this is really a U substitution. It's only scaled by constant. Somebody tell me what's the antiderivative of this? Good. Yeah, this is checkable. U is what's let go. You put your U and dV together, you should get x e to the 2x dx. And now what's your du? Is 1 dx. So let's see what happens here. This should be uv, which is 1/2 x e to the 2x minus this cross. And this is another 1/2 e to the 2x, so I get 1/2 x e to the 2x minus 1/4 e to the x. From taking the antiderivative of this, it's 1/2 times another 1/2 e to the x. You know what? You want to check me on that? Take the derivative. That's right. Take the derivative of this. It's e to the 2x times 2 times 4. 2 cancels. Makes sense. Okay. Sometimes you have to be. Let's do numbers right here. Let's say 0, 1. Let's do the interval from 0 to 1. Yes. Okay, what's the biggest, ugliest piece of that you can integrate in your head? What do you think? What do you want back for D-Day? Yeah, I can integrate that, but. So let's try that. So that forces your hand on you. Let's see if that very pretty screen. So execute, right? So this is going to be product of these two. Execute. Next. And at this point, I'm going to put somebody coming by. Might not be. Somebody look at my original situations. Right. Here I have a square. Now I've got a cube. It's not going wrong. Let's try it. I think the biggest ugliest piece that I can do, probably the EDX. Let's try these. Again, we'll put it back together. Now, this gives me the 3x squared EX minus cross that 6x next. And now I'm annoyed because I'm still not done. Right? Now I've still got an x e to the x that I've got to deal with. But can somebody explain to me why I'm better off than I was before? my exponent has dropped from the beginning of the problem. I had an x squared times EX. Now it's dropped to an x first times EX. That gives me a little bit of hope. What should I do? What's it? Well, right, but I still need an antiderivative of this before I can do that. I'm still gonna get that. Just once again. Nothing stopping me from doing that. Here, I want you to be 6x. Now be careful with minus. U is 6, dx is dx. So, I'm gonna be, I hope, super careful here. This is equal to 3x squared dx minus. Now I'm doing the parts for this. This is going to be 6x dx minus so let me clean this up. Because of this minus sign, you can really easily mess up parts. Be sure that you track it. This is going to be 3x squared dx minus 6x dx. All value at 1. And minus minus, so it's going to be plus 16. One more step. With that last antiderivative, and plug in the numbers. Right. Okay, let's do this. When I plug in 1, I get 3e minus 16 plus 16. 1 to 0, I get 0 minus 0, 6. So I get something crazy like 3e minus 6. Question. Okay. Need a part bring this. Yes. Well, yeah, if you have to do it multiple times. Right? So it's always, you've always got those parts to see the formula back together and integrate. If you can't integrate, you'll have an extra interval. Just let's look at the derivative of log x is one over x, but anybody know what the antiderivative is? This is a great one. I mean, good luck with the substitution, right? It's nothing will work out well. And this also illustrates another important control. What's the biggest, ugliest piece of that you can integrate sort of in your head? And please don't say log x, because if you can integrate log x, just write the freaking answer down, right? You can't do log x, otherwise I just write it, right? If this is the integral of e to the x, I just write e to the x, I want to start the parts on it. You don't see a part you can integrate, right? Because there's only one part, but there is. There's one. Always a one. Do that. And believe it or not, this works quite often. No choice here. You're left with log x. You got to check again. If you put these back together, you should get log x. So, du, what's du here? X. Dx. D is x. So using the parts formula, this x log x minus the integral of x 1 over x dx. Like x log x minus dx. That was like x log x, antiderivative of 1 is x. And again, just like yesterday, all your answers are checked. Take the derivative of this product rule, 1 times log x, there's log x, and then x times 1 over x, which is 1, that's minus 1 which cancels. Any questions? What? Oh, so maybe I'll just leave this over here. That's essentially. Notice that the original one is UDV. This is UV. And this is V. So it's the product of these two minus this cross. Is that what you're asking? Like this. So so what do you think? Stand up, that's where What's the biggest simplest piece? That thing should be very sort of in the head. What's that? I don't know the answer. I know the derivative. I agree. Let's try. So I think this is the kind of the most complicated, biggest piece of this thing. But, writing something down, and that's my DD, and what's left over is. So let's figure out what everything is. What's D going to be? What about A? One third. X. So my parts formula tells me over there in orange that it is UV. So it is 1/3 x cubed inverse tangent x minus the integral of 1/3 x cubed x squared plus 1. Okay, so okay, instead of now I've got something. Only how do we do this? You were correct. Substitution unit problem will work if you work that. I'm going to do something else to show you something else that should be in the trick bag. Again, I'm going to use an algebra. I'm going to divide this. I'm going to divide x squared plus 1 to 1/3. Now, let me put this down here. Sorry. How many times is x squared going to 1/3 x cubed? What do you got to multiply x squared by to get 1/3 x cubed? 1/3 x. This is just like old-fashioned long notation. This is 1/3 x cubed plus 1/3 x. And I subtract. When I subtract here, I get 0. How many times is x squared going to 1/3 x? Well, it doesn't. It's power here is 2. So this is 1/3 x, remainder negative 1/3. So this means that x cubed, or I'm sorry, 1/3 x cubed over x squared plus 1 can actually be written as 1/3 x quotient plus remainder over x. And by the way, if you take this side right here on the right, you find the common denominator x squared plus 1, put it back together and get this. Now, what's the point of this? The point of this is to get this in a more palatable form. That's just my algebraic rewrite. Now pull that minus. Now I can integrate this. This is going to be -1/6 x squared. And this minus plus 1/3 x over x squared. Any questions on any of this? Now, I've just got one more thing to do, and that is figure out what this is. And, Emery, you were right. I could have done it while I'm here. I didn't really have to do this in this problem. There's some problems where you probably need to do this. But here it's a little bit more clear. U equals x squared plus 1. Well, actually, let me be organized like this. I'm going to do a little side. This is the last one. I want to find 1/3 x. I'm going to find the same type of derivative here. This was the U substitute. The U is 2x. I've got a match on the right power on top. I need a 1/3. So let's do this here. 1/6 U is 1/3 x. All I did is multiply by 1/6 to make this. Right. So this. 1/6. Third x again. Over here. 1/6 natural log absolute. And this is 1/6 natural log x squared plus. To finish this all off, my final answer is 1/3 x cubed inverse tan x minus 1/6 x squared plus 1/6 natural log x squared plus 1. This actually shows you the power of the in, because it's not clear, but try it if you like. When you take the derivative of this, if it's squared. Okay, I'm going to do another multi-stepper, and then another multi-stepper after that. Let's do this. Let's find the anti-derivative x cubed. Actually, it's no. By the way, how many you better guess how many steps parts I've got to do before I answer. Good. What made you guess that? You are right. You just supposed to use the fourth, right? Okay. What's the biggest nasty piece of this that I've been embraced with? Well, right, but when I do the X cube, if I make that my DB, that's going to increase. I can, cosine is, I consider sort of, I mean, it's a matter of opinion, more complicated function. I can sort of do that in my head. This is going to leave me with X cubed, so I've got a match here. Let's do the gut check. The derivative of X cubed is 3x squared. Now let's see if I can follow through on my big mouth about saying I can do this in my head. What's the antiderivative? Cosine X is cosine 4x. You got to think it's little. Sort of like that, not quite. How can I adjust it? But it's positive. Right. So if you check this is derivative, right? So basically, it just says constant. Everybody okay? Okay, so in the first step, parts, I get the product of these 1/4 x cubed sine 4x minus integral looks like 3/4 x squared sine 4x. Now, let me, so first of all, does everybody follow what I'm saying? Now, my situation is better, I think, because I had a cube times a trig function. Now I've got a square times a trig. So I seem to be going in the right direction. It is tempting to pull that 3/4 out of the interval, right? And that is certainly a legal move. Do it. Don't do it. My experience with this is it's better to leave this chunk inside because what happens in parts is you keep nesting this minus integral, and you keep doing that. And every time you pull a constant out, you've got to multiply it back later. You're just asking for trouble. So I really would suggest leaving constants. Let's simplify. So parts again. Do what worked before. Do 3/4 x squared. So the derivative of 3/4 x squared is 3/2 x dx. And your b, your antiderivative, what's that going to be? Minus 1/4 cosine 4x. Agreed? And again, you can check yourself along. Okay, let's see what we've got now. This is 1/4 x cubed sine 4x minus this interval. And this interval is my new parts, right? So it's the product of these two, which is minus 3/16 x squared cosine 4x. Product of these two, minus 3/16 x squared cosine 4x. And then minus the interval of this product. And this product here is minus 3/8 x cosine 4x. Minus 3/8. But it's okay, see what a freaking mess this is, right? Minus, there's more minuses than you shake a stick at. This is why I recommend not pulling out constants. Let's settle up at this step. Let's clean this up so I don't confuse myself. 1/4 x cubed sine 4x plus 3/16 x squared cosine 4x plus minus 3/8 x cosine 4x dx. What's that? Which interval? This one? There is.
I was saying you didn't bring it down.
Minus, that's a plus. So do you agree with this piece?
No, I was thinking the inside of the bottom should be negative 3/8 x sine 4x under rewrite.
Oh, right. Negative, positive, and another negative. That's, and I'm glad, this illustrates what a pain in the, you've got to be careful, right? So everybody see that? There's a negative here that's multiplying that positive. And that's why I recommend also taking a step. Now it's better for. And now I've got it down to a single power vector. So one more. X B is cosine 4x. So there are my pieces. This B, we've done this before, is 1/4 sine 4x. And du is 3/8 x. So this is 1/4 x cubed sine 4x. Plus 3/16 x squared cosine 4x minus. Okay, so we've got this part again. This is going to be 3/32 x sine 4x seconds minus the integral of 3/32 sine 4x. And this piece right here, ostensibly I can do in my head, because it's constant, right? Antiderivative sine which minus cosine minus 3/128 cosine. But then it's minus. So final answer should be 1/4 x cubed sine 4x plus 3/16 x squared cosine 4x minus 3/32 x sine 4x minus is plus, then another minus 3/128 cosine four x. Wow. Let's see if this works. Yeah, it's okay. Any questions? Notice we did have to do parts three times. I'm gonna get down to this. Questions on that? Sine of the square root of x. This one is parts as well, but it might be easiest to do a substitution. Right? You don't have to, but we will. Let me do a substitution part on this. Everybody agrees that the square root of x is kind of problem things up a little bit. So let's do this. And instead, so z is the square root of x. So my philosophy here is I'm going to turn that into c, right? Let me do something else here. Let's write that z x, or I'm sorry, x is z squared, right? Remember how oftentimes it's easier to do the substitution if you can write x as the other variable. So if x is z squared, what is dx? So this, my first substitution, allows me to turn this to sine of z, and the x is 2z. Now it's kind of about to go into the easier to see what you mean. So let's let u equal the biggest, nastiest piece of this that I can integrate in my head. So the sine of z, and this leaves the other piece to be 2z. So u to b times cosine. So parts formula is the following. Minus 2z cosine z. And then plus 2 cosine c. Because it's minus minus. And this one, I can get. Okay, I'm not completely done here yet. What's one more thing I should do? I need to flip it back from my variable X. And I can see the spurred backs. You could have done this directly. My parts skipping that intermediate step, but sometimes a photo substitution helps to more easily see. Although even if you're going to try parts here I think are more obvious because you're really your only choice is to make this you. Any questions? Okay. Here it is. So what have we done? Notice every single example we've done in parts, what happened? We did parts, we solved it. Or maybe we have to do parts twice, we solve it. So if we do parts until we get to an interval, we solve it. Right? And sometimes we have to do a use substitution before or after one. There's one more kind of parts, another kind of sitting. And I'm going to do it via the following. You see exponentials and cosines, exponentials and sines. Either the AX cosine DX. What's the biggest ugliest piece of this that you can integrate in your head? Actually, this one, it doesn't matter. Either part will do, but you have to stick to it. So I'll go with your choice. So she says, I'm going to integrate cosine. I agree that's pretty good choice. They're my points. Let's see what else we get out of this. Between sine x and d, or I'm sorry, du is e dx. And so this immediately becomes something here. Is according to my parts formula, it's e to the x sine x. Minus the cross interval, e to the x sine x dx. They don't have a different interval anyway. Huh. Let's try parts again. Yes. Well, here's the stick you guns for. Notice, just like when we started, you got an exponential and a trig function. Make them play the same roles. That is to say, I use the cosine first, now I use its antiderivative sine again as dv. Sorry. So I'll pick up where I left off. This is e to the x sine x minus, let's see, part here is minus e to the x cosine x minus minus and now somebody tell me why PO. Look at this. I'm back to my right. It's starting over, right? And this is not a John Lennon album. So let's try to figure this out. So this is e to the x sine x plus e to the x cosine x minus e to the x cosine x dx. Oh dear, what will I do? Right? Because now I'm back to where I started. Yeah, it is. Keep in mind this whole thing right here is a rewrite of this. Everybody agree with that? Because this is where we started. We did our magic twice, and this thing is equal to this thing, right? Everybody agree? This is an algebraic equation that you can solve. Right? Bring this over here. What I get is this thing right here, e to the x sine x plus e to x sine x is equal to 2 of these integrals I was looking for. Everybody agree with that? So just solve it. Divide both sides by 2. Always be mindful of that. If you get back to where you started, you might be able to solve it. Any questions? By the way, let me ask you a question. Do you remember this step here when I said stick to your guns? And I said, okay, you do the same. What do you suppose would happen if you didn't stick to your guns? What would happen if you didn't stick to your guns? It's like untying your shoes. What would happen here is you would get an equation where everything on both sides cancel. And you get the equation 0 equals 0, which is a true equation, but useless. Right? So if you don't stick to your guns, what will happen is everything cancels out and get 0 equals 0, big tears. And you know that what you did wrong was that you didn't stick to your guns. So you go back and fix it. Yes. So in this situation, no, the one you're talking about is repeated stuff, didn't repeat itself. The power actually jacked up one. Right? We went from, and the reason I said that one got worse is because I started with like a square times an exponential, or maybe a square times a trig function. And then I got a cube, and it's like if I keep doing that, I'm just climbing fairway to heaven. Okay. Let me illustrate this here. Try and erase that. Here's the final answer. Okay. Let's do it. This is one that I think. Let's see. Sine 2x, sine 3x, I think sort of equally complicated, so I'm just gonna pick one. Derivatives and whatnot. The antiderivative of sine 2x shouldn't be minus 1/2 cosine. Everybody agree with that? So let's see what happens first, Jack. This is five of these two, so that's gonna be minus 1/2 sine 3x cosine 2x. I'm just trying to find the same thing here, so I'm just solving. Right, and so here's the end of the last problem. The derivative of this function should be that. Right, that's what it is. When you just see an open interval sign with no, that means I'm finding the end of it. And that's what I'm gonna try to do here, find something derivative, it's sine 2x, sine 3x. Wait, okay. And let's see. Part says plus 3/2. Let's say cosine 3x, cosine 2x. Yes. That's a great question, and the answer is yes. I'm gonna come back to that. Yeah. But here I'm gonna go through the parts. So again, I've got to stick to my guns here. Well, what's the appropriate gun? It looks like I used the 2x for DD, so I'm going to use the 2x here. Right. So the other piece should be 3/2 of some 3x. So u equals minus 9/2 sine 3x. Yes. And b is 1/2 sine. So this is equal to, you can see what the parts gives me now. This is minus 1/2 sine 3x goes to 2x. And then I've got to see plus this contributed by parts. This should be 3/4 cosine 3x sine 2x, yes. 3/4 cosine 3x sine 2x minus, so that's minus, so it's going to be plus 9/4 sine 3x sine 2x. Everybody okay? What's 4 sine 3x? Hear me? All right, so let's see. This is minus 1/2 sine 3x cosine 2x plus 3/4 cosine 3x sine 2x. And this is going to be plus 9/4 integral of sine 3x sine 2x dx. And we're back to where we started again. Just like before. Remember, after all this work, remember where we started. This is equal to the integral of sine of 2x sine 3x. 9/4 spread, this is spread, so I get minus 1/2 sine 3x cosine 2x plus 3/4 cosine 3x sine 2x is equal to, looks like minus 5/4 sine 3x sine 2x. And so at the end of the day, if I solve this, sine 2x, solve for this, I've got to multiply both sides of the equation by -4/5, kill that. So -4/5 times this is going to be positive 2/5 sine 3x cosine 2x. -4/5 times this is minus 3/5 cosine 3x sine 2x plus. So I tried to. So the very end. Right. All this is work. It started right here. And so do you know why this equals this? Because this is what we started with. Right? This equals this equals this equals this. Don't forget, this is where we started. Right? So I've come full circle. I'm just pointing that out, right? So I can solve this. And let's see what multiply both sides by -4/5. Just the reciprocal, the inverse of this. Because I want that to be a 1, because that's what I'm solving. Right. So think of this as, so let me make this simple. Here's the, except I don't have my right on that. This equation really right here says minus 5/4 times the right side is the left side. Right? So how do I solve this? L divided by minus 5/4, which is minus 4/5 L. That's see if this, that, it's negative. There's plus 9. Six. That's right. Now, you said something actually interesting earlier. I'm gonna give you some free ideas. And again, if you ever want these, they will be free. But this is really nothing I'm like. See if I can do it. Cosine. Cosine. Sine. Cosine. Cosine. Sine. That's right. Finally. Sine. These are trig identities that you may have seen in trigonometry before, and you can certainly find it in here. This is basically, here's where this comes from, for example. Let me show you, I'm just not pulling this out of thin air. Somebody, you all remember that cosine of A plus B is cosine A, cosine B, minus sine A, sine B, right? Maybe you didn't remember the identity, but you know that it exists, right? The additive identity. And sine of A plus B is equal to sine A cosine B plus cosine A sine B. And for example, for this first one right here, it turns out cosine of A minus B. Cosine A, cosine B, plus sine A sine. So for example, this first identity comes from, if you add these two equations right here, you get cosine A plus B plus cosine A minus B. Adding these two. Notice on the other side, these two terms cancel out. And this is 2 cosine A. Cosine. So you can divide out by 2, and you get this first identity that I gave you. So what good is this? Let me do this problem. So we have sine 3x, sine 2x, dx. 1, 2, 3 identities. To this problem, which one of these three is probably relevant? Sine A sine. So here, I want A to be 3x and B 2x. And this identity allows me to rewrite it as sine. I'm sorry. That 1/2 cosine of 3x minus 2x. Minus cosine of 3x plus. Right there with that? Now. So this is the interval of 1/2 cosine x minus 1/2 cosine 5x dx, which is 1/2 sine x minus 1/10 sine 5x plus 5. Right, okay. So guess what I just did? I gave you a new trig identity. Let's figure one out. Probably never seen this. Well, I haven't. The derivative of this thing is this. The derivative of this thing is also this. So I have the following identity. 1/2 sine x minus 1/10 sine 5x is equal to 2/5 sine 3x cosine 2x minus 3/5 cosine 3x sine 2x plus constant. And in fact, so remember these two things are both antiderivatives, the same thing, and it's vary by constant. Notice when I plug in x equals 0, I get 0, 0, 0, so C 0. So let's see. I guess I can clean this up a little bit, multiply by 10. So this is 5 sine x minus sine 5x should be 10, so 4 sine 3x cosine 2x minus 6 cosine 3x sine 2x. Probably never seen that. There it is. And actually, these things right here, I'll use these identities on. I'm sure we can do that. If we balance out. Okay, any questions? I'm going to give you a little break. And if we can't figure it out, we should probably change the major comparative literature. I am going to prove to you that 0 equals 1. So we need to resolve this one because otherwise my life's working crap. So please save it. Okay, we all know that. What's the answer? That's what I got. Right, but I'm feeling on power with my new knowledge of integration by parts. So I'm going to give that a go. Let's try parts. Well, UV 1 over x and dv is dx. Let's just try it, right? Certainly, if I put that back together, I get 1 over x dx. So let's try this here. So du minus 1 over x squared and d is equal to x. Agreed? Now let's use parts form. What's UV? So it should be right minus the integral of great. So what I get is here's where I started. This is 1 minus is plus. Right, it's minus is canceling. Now, here we have the integral of 1 over x, same side of the equation, subtract it off, and I get 0. 1. Right? I'll see what I did. I subtracted off the integral from both sides. So now 0 is there. Better be something with that. Please let there be something wrong with that, because otherwise, math is useless. Anybody know what's wrong? Right. Well, let me ask you this. What did I do? Go from this step to this step. Right. What is this that I subtracted off? It's an antiderivative of 1 over x. When I subtracted these off, I assumed they're the same thing. I have 2 antiderivatives of the same function. Are they the same? They can differ by a constant. Very good, very good. Right, because it's not really fair for me to subtract this integral both sides, because they're not necessarily equal. They can vary by. Right? So, any questions? Okay, so we will start the quiz now. I will give you guys a good run for it. I have 6 of them on there. There are some integration by parts, but they're not all parts, right? So use your judgment on that and do your best.